Hello everyone. So in this video, we will talk about linked list. If linked list had a double linked list in the LRU concept. Okay, that is the least recently used. So earlier video I taught about with Hashmap and linked list. There we have a time complexity of O of n. But now we will use Hashmap and double linked list. Okay, so this will give us a time complexity of O of 1. Okay, I'll write the code for double linked list, like we will implement our own double linked list, and then we will check the code. Okay. And after that, I'll also take up this linked hash map. So this is an internal collection available from Java. So even that is much more easy solution. But firstly, we will understand how it actually works in the backend. Okay, let's just go to the code. Yeah, so I've created one folder, LRU optimized double linked list. Okay, let me create new Java file. Okay, so firstly, we will create our double linked list, our own double linked list. Okay, so I'll just create the class. Okay, and what else we will be needing? First let's check this only. Okay, yeah, now we have to create double linked list. Now let's just think it practically. What all we will be needing? We will be needing head, tail, and functions like add, remove. Okay, so these functions are the basic functions which you will be needing. Okay, so we will construct all this over here. uh, I'll make my no, I'll make two node, that is head. Okay, I'll be needing, okay, there's I have not created the node class, sorry. So first I'll create a node class. That's basic thing we should do it. See, that's how we learn. So node class, okay. Now, node class is definitely two things we needed in this. We will have, okay, so I'll just make it my integers public, sorry, I just wrote p caps, public integer. Okay, so this will be key. Okay, and we will be needing public string. Okay, so this will be my data, sorry. Yeah, now we will definitely have a yeah, it's a double linked list, so we need next and the previous node. Okay, so it will be public node next and public node previous. Okay, so these two things are required. Okay, spelling mistake, now it's correct. Okay, let's just go to our constructor. Okay, so we will be taking input our key and our data. Okay, I'm just initializing it, a simple, just straightforward, assigning key to key. Okay, and then assigning data to data. Okay, so this means I'm taking my class variables, and the equal to, after equal to sign, whatever variable name you are seeing, that's coming from the function. Okay, so that's why we use the this key. Now let's just go to our class. We have created node head. Yes, now it should not be having any issues. We also need tail. Okay, so these are two things we need. Okay, uh, for we will create our constructor. Okay, so this will take an input of like we don't need an input. Okay, the moment we create it, we will initialize it. That's what we will try to do. Okay, so I'll say this dot head, I'll be creating a new node. Okay, over here, and I'll pass null only. Okay, and similarly I'll create my tail. Okay, yes, and null. Yeah, that's what I'll keep it, and I'll initialize like the next which we have to do. So it will be head dot next will be my tail. Okay, I hope you guys knowing the double linked list concepts and all. So uh, my next will be pointing to the next node. Right now the tail is my next node. Okay, and similarly I have to assign previous also. So my tail dot previous node is nothing but my head node. Okay, so this makes right now my linked list or double linked list only with two nodes, head and tail. Head next is pointing to tail, and tail previous is pointing to head. Straightforward. Okay, now let's go to the functions. So we will be needing functions like add first, okay, remove last, okay. So I'll be creating the functions like that because we will be doing our operations majorly on this, okay. So it will be public first function we will write for add first, okay. So add first. Oh, spelling mistake again. Yeah, now it's fine. Mm. So in this we will pass our node, okay. Now we have to add this node first. That means after head, okay. So my head is null, it has to be added after head and before whatever is there, okay. So it should be just after my head. So how now I will write it down, then maybe we will picturize and think of it how it's going, okay. So it will be like my node dot next will point to my head dot next, okay, because I have to put it in between head and the first whatever node was there, okay. So my node not next should point to the head dot next. I hope you are agreeing with me. Okay. Now next thing we will do is node dot previous should also my now node. Okay. Now I have to place it my node after the head. Okay. So node dot previous should be assigned to head. Okay. Because my previous will be head. Okay. Yeah. Now next thing comes up is like now that imaginary node, that node is there which we don't know, is it a tail node or some other node. Even that node previous we have to assign it to node, our node. Okay, so it will be like head dot, we will go to next. Okay, so that node right now we are at that node and previous. Okay, so this is a previous, this will point to now node. Okay, so this is how my node will come in between. There's one more way we have to do it, we have to also do for the next. Now my head dot next will point to the node. So this is how we replace node at first position. Okay, so head will come after that, this my first node will come. Okay, so this is how we'll write down add first. Okay, I'll keep my head as a null. Okay, that's how I want to write it out. Okay, so head is done. Now we will write the other functions of remove. Okay, so public again a void over here. Now we will have remove. Okay, now we will be getting a node to remove. I think remove is very much simpler, easy to understand. It's very straightforward, like you have to just remove one node, so from between, so left and right, you will just equate them, like assign each other. Okay, so it will like node dot my previous node, okay, dot next. Okay, so my previous node next will point to my node dot next, straightforward. Okay, so I'm just removing, I'm directly linking my previous node to my next node. Okay, and similarly I have to do it for next also. So node dot next and then previous, okay, will point to, sorry, will point to my previous node dot previous. If you guys not understanding, okay, let me know, I'll make another picturize of it and then I'll explain it properly. But if you already guys know it, then it's very much straightforward. Okay, if you are, and one more suggestion to you, if you are not getting it right now, write it in the paper somehow. Okay, make the blocks and then see next and previous how it's going. If you're still not able to figure it out, let me know, I'll make it that out. Okay, so this is how we can write the remove. Now we will write a function to move to front. That's what we will do. Okay, so it will be like again public void move to front. Okay, now here we will again be getting a node. Now you will be thinking add first and remove are already there, so we can use them directly in my move to front. So what we have to do first, we have to remove. Okay, so we'll provide the node to remove. Then we'll say add first. Sorry, add first and then provide the node. That's all. So we have moved our node to the front. Okay, now we need one more function to remove last. Okay, these functions are required again for handling the least recently used cache. Okay, so it will like public. Now a remove function is there. Okay, so I'll be needing the node back. Okay, because I'll be removing them. I'll be because I have to remove it also from cache, you will get to know where I'll use them. Okay, so you can see this function is returning a node right now. Okay, now remove last, so we have to check is it a end node or not, is like a tail node. Okay, if it is my tail node, then I'll not remove it. Okay, because I'll keep that. Okay, so yeah, so we will do that over here. So if tail, sorry, tail dot previous. is equals to my head. Okay, that means my there is no node existing in my linked list, double linked list. Okay, so that's why we will return null. So it will be returning null, nothing to remove. Okay, now next thing, if that is not true, so we have to remove the last. Okay, so we will take node remove last. Okay, and this will call, we have a tail pointer available. Okay, that's the beauty of O of one. Okay, here in earlier video we were using the linked hash map and we have to track that node completely and then remove that. But right now we have a tail node, tail pointer available, so with that pointer we get to know which to remove. Okay, so previous, that's how we will do it. So this node we have to remove it off. Okay, now we will call our remove, sorry, yeah, remove function, and we will pass the remove node. Okay, so remove last, and then we will return this remove node. I should have written remove node, not remove last. Okay, let's keep the naming convention better to understand it. Yeah, so I added this also and done. Okay, so these are the functions which we will be using them. Okay, yep, add first, remove last, and then in between add and remove, that we have used it. Now let's create our LRU class. Okay, so it will be our new class that we will create it. Let's name it LRU, LRU optimized, LRU optimized, yeah, double linked list. I'm just writing a bigger name. Okay, bear with me, with hash map. I find this should be fine enough. Okay, yeah, this is an optimized way. Okay, O of one. So let's just think what all, again similar things, like we will be needing capacity. Okay, then my cache, and then for order I'll be using double linked list. Okay, if you are from the last video, then you will be knowing this. Okay, if still no issue, let's just write it down. Okay, so it'll be private final, we will be needing int capacity. Okay, this is done. Now we will be needing other cache and my that order. Okay, so private final. Now the catch is over here. Okay, this is one important thing. When we create a hash map over here, we will create of integer and node. Okay, this is important thing, we will hold the complete node in the data. Okay, otherwise in the linked hash map we were just directly storing the data. Okay, but no, here we will hold the node. Okay, that's how we will get use this. Okay, so this will be cache. Map is not imported, sometimes it throws an issue, so I'll say quick fix dude, please import it, import. Okay, yeah, it's private final now, that's why it's showing red or error right now. We will rectify that, no issue. So I'll be needing order also. Okay, so first let's just keep it private final, and here I'll use my own class, my double linked list. Okay, and I'll provide, yeah, so this will be one, and it will be of I'll name it as order. Okay, now, yeah, now we will go with our constructor. Okay, because we have to define all this. Yes, we will be getting an input of capacity, sorry, in this bigger capacity. I'll be taking this input, I'll be assigning it this dot capacity equals to capacity. Okay, now this is done. Now we will be initializing our hash map and a double linked list. Okay, so it will be this dot cache equals to new hash map. Yes, okay, and yeah, now the thing is like when we are creating a hash map now, we will define the size of it. So this will be our capacity, we will tell this is what the size we want. Okay, if I'm passing 5, 10, 8, and whatever 9, so this is the capacity. Okay, there's one more thing which we have to define, this dot order. Okay, now this will be our new double linked list. Yes, straightforward as that. Okay, see, now all the error gone. Okay, yeah, now we'll come to our main two functions, that is get data and add data. Okay, so we will just write those down. Public add get data first. Okay, so it will be string, and get data, we will be getting key over here, straightforward. Okay, yeah. Now let's just think what all we will be needing, like how we were thinking in the previous example. Okay, so we will first check if data exists or not. Okay, yeah. So for that we will have a cache check. So it will be like same thing, we will do it as last one which we did. So cache dot contains key. Okay, yeah, I'll pass my key. Okay, yeah. Here what I'm doing, if it is not existing, I'll just return no data for this key. Okay, like last, similar like last time. Okay, no data for this key. Okay, straight. Now if it is existing data, we have to get that data and we have to move it to the above recently used. Okay, so you'll remembering it, right? So firstly get data and move it to recently used. Okay, this is what we have to do it. Now let's just see how we will do. First we will get that data. So node equals to, okay, so we'll say cache dot get and we'll pass the key. Okay, so we got the node. Now we will move it to the front. Okay, so it will be like order. You remember the function of we have moved to front. See, this will help us. So we'll pass the node. Okay, and then we will return the data also. So return node dot data. That's all. Okay, so we return the data also, which is a string format. And see see now how we are easily getting this function move to front. What this actually move to front will do is like, will actually wait, I'll open this one right now for you. Yeah, so you can see move to front, first we'll remove that node and it will add first, straight as that. Okay, so that's what we wanted. Good. Now let's go to the other function of public. Now that is an add data. So return type is not required. Okay, and we will be getting key and data, sorry, string data, to be proper, string data. Okay, yeah, this is fine. Now we will do an add data. Now let's just think out what all we will doing, similarly like last video. So we will be checking if that check if the key already exists. Okay, if yes, update it and update it and move it first, move it to first. Okay, and second part is like if not existing, check for capacity and add it, straight as that. Okay, so this is what we will do. Okay, so first let's do the first thing. Okay, so if cache dot contains key, we will pass our key. Okay, so if it is containing, what we'll do, we will, if it's already existing, update it to the update it and move it to the front. Okay, so firstly, sorry, I came down, I don't know how. Okay, so we will be getting the node. Okay, so first we will get that node. So cache dot get, we'll pass the key. Okay, yeah. Now what we'll do, we will get the data. Okay, and we have to update the data. So node dot data, we have to update it with the new data. That's what we got it. So we have updated the data. Now we will move it to the first. So it will be order dot move to front. Yes, and then we'll pass the node. That's correct. Okay, see, that's how it will be done. Okay, so we updated the data and we also moved it to the front. Okay, now let's just go to the else part. Okay, now in the else part, yeah, this is what we have to do. If not existing, then check for capacity and add it. Okay, so this is what we will do it inside over here. Okay, so we will say if my cache, okay, now I'll check the size of a cache. Okay, if the check cache size is greater than or equal to my capacity. Okay, now capacity I will define it how much I will need it. Okay, if it is fulfilling this criteria, that means it is hitting my capacity. Okay, I'll take it in. I have to remove something now. Okay, so I'll say remove last. Okay, node, I'll say remove last. Okay, and I'll call my function of order dot remove last. See, we got that node last remove. Now we will remove this from our cache also. That's why we need this. Okay, so cache dot remove, and we will pass remove last dot our key. Okay, that's what we want to remove from our cache. Okay, yeah, I hope you guys would have understood it. Okay, so that's why I was written return node for the remove last function. Okay, now I'll go to the, after removing we have to just add it the new whatever key we are getting it to. Okay, so it will be node, we have to create a new node. Okay, it will be new node equals to new node, and we will pass the key and data. It automatically took it, so that's good. And then we will move it to the front also, so it will be order dot move to front, the new node. Okay, and we will also update in our cache, so cache dot put, we will say key is our key. Oh yeah, sorry, key is our key, and then new node. That's all. Okay, so this is the code. Okay, I've written twice. I'll remove this. Yep. Okay. Yeah. So we have written add data and get data. Okay. Now we will write our main class so that we can run it out. Okay. I'll just create a new class. I'll say test main. Okay. Test main. That's what I feel like writing. No issues. Okay. Now here what we will do, we will similar thing, we will create an instance, and then that's how we will go. So we need a main function. Yeah, good, it worked this time. Okay, so we will create our class. Yes, see, the name became too big, dude, I should have written it small, no issue. And we will define a capacity of 3. Okay, that's what I'm doing it. If it is becoming too big, what I'll do, I'll just hit an enter over here for you guys. Okay, yeah, now it seems fine. Okay, so firstly we just created an object. Now we will add the data. That's what we want to do. Okay, yeah, okay, it has taken a very short name, that's a good thing. Okay, so linked list with hash map, so dot add data, we will add similarly like last time. Okay, so this is one data, that's what we were writing it last time. Okay, I'll copy this, and you will use this 3 times. So this will be my 3, this will be my 3, this will be 2. Okay, this will be 2. Okay, so we added it. Now what we will do, yeah, similar like last time, so we will first call our 1. Okay, so I'll say s out, and I'll say link hash map dot get data, and I'll pass the key 1. So now you guys would be remembering it. So this will move my move key 1 to top. Okay, this is what I wanted. Now if I add new, if I add not this one, sorry, if I add if I add a new 4, okay, linked hash map dot add data, this will remove the second key because my 1 has moved to the top. Okay, this is 4 data. Okay, I'll just write it down for you guys. This will remove 2 key. Okay, because 1 has moved to the first one. Even just let's see it by printing it out also. Okay, so I'll say system.println, I'll say linked hashmap dot get data for 2. Okay, so yeah, last time we remember we didn't add it, so we will add this also over here. Okay, we'll say for 1 key. Okay, like this, and similarly over here also we will add it for 2 key. Okay, This will get we will get to know what it is printing basically. Okay, it will print it will definitely print no data for this key. Okay, now we will add our new key, that is 5. Okay, at first 5, and then this is 5 data. Okay, yeah, and then the moment we add this 5, this will remove third key. Okay, we will test it out also, I'll show you. Okay, so s.println, again we will say this is for this is this say for and we will keep the same indentation for third key. We will not get the data. Okay, so it will be linked hashmap dot get data lpass 3. Okay, yeah, I think so this what we should do it now. Let's just run it and then see it once. Okay, so guys, I found a issue when I was creating my add first class. Okay, so in that I wrote move to front, and this move to front will call the remove function. Okay, that's what not that we didn't want it because we are adding it first. Okay, so I should have called the add first function. Okay, so I just updated the code with this right now. Okay, that's why it was breaking. The below error was because of that. Okay, now let's just go and run it. Okay, yeah, see, for one key this is the one data, we got the data. For two key, no data for this key, and for key 3, no data for this key. Oh, I think I forgot to add a yeah, this one. That's why we got joined. There was no space. Yeah, see, for this key, no data for this key. Okay, so this is how we will implement the LRU with O of 1 time complexity. I'll tell you now how the O of 1 time complexity we are getting. Okay, in the earlier code we were removing from the linked list. Okay, when we were doing get data, we have to remove from our linked list and move to the first one. But here you can see I'm just getting the node directly and I'm passing to the move to front, and this move to front function, what it was doing, it was directly getting that uh, node and it is removing it. Okay, remove function is very much straightforward because I don't have to track that node. Now I'm getting the node directly to the double linked list. That's why I don't have to go till that node. Okay, I'm directly getting it from my cache. Okay, that's the reason this becomes O of 1. Okay, that's why I told you when we were creating this our class, this map of integer and node, this is like the most important thing over here. The moment you created a node in the value, we will get a node back when we have to delete it. And if you have to delete that node, it's very easy in double linked list. Okay, because previous and next we will just assign each other. Okay, that's why, that's the reason it become O of 1. We got this data to add data in O of 1, or even get data in O of 1. Okay, so I hope you guys would have understood. If you still have any questions, okay, put it in the comments. I'll check it out. I'll update my code, and even for this, if the generics code is needed, okay, like right now you can see, yep, I have created my class where I'm taking key as an integer and a value as a node. So we can even create generics over here, k and a v. Okay, if you need that code also, put it in the comments. I'll update the code. Okay, I'll create a new code for that. Yeah, that's all for this video. See you in the next part. Okay, where we'll use the internal collection from Java. Okay, yeah, thank you. Bye bye.